In this video, we want to find natural numbers n and p such that this expression is the same. Let's start off with the right side of the equation. We know p squared ends with the numbers 0, 1, 4, 5, 6, and 9. So this is just a common fact that you should know. Okay, now we'll add 5 to this. So basically take whatever numbers you have here and add 5. But you want to be careful because when you add 5 and you get over 10 and over, you have to look at the last digit. So let's say 0, 1, and 4, if you add 5, you get 5, 6, and 9. With 5, if you add 5 to 5, you get 10. That ends with a 0. If you add 5 to 6, you get 11. That ends with a 1. And if you add 5 to 9, you get 14. That ends with a 4. So that's how we were able to get these numbers here. Now let's look at the left side of the equation. But first we have to look at n factorial. Now n factorial is just, it's going to end with 0, 1, 2, 4, and 6 because if I have a factor of 10, that means my number has to end with a 0. Because 10 times anything ends with a 0. Well, when does that happen? The first time it happens is when I have 5 factorial. Because that's when I have 5 times 2 in there. So I'm going to get unique last digits from 1 to 5 factorial. And we'll see that in the next slide. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, that ends with a 4, and then 5 factorial is 120, that ends with a 0. Now 6 factorial, 7 factorial, etc. all have a factor of 10 in there. So they're also going to end with a 0. Now I'm going to add 3 to this. So take all these numbers and add 3 to each one of them. And then finally we're going to multiply by 6. So with this, just take each of these, multiply by 6, and look at the last digit. So 6 times 3 is 18. That ends with an 8. 6 times 4 is 24. That ends with a 4. 6 times 5 is 30. That ends with a 0. 6 times 7 is 42. That ends with a 2. 6 times 9 is 54. That ends with a 4. Okay, so I should also mention that the only two digits that they both share in common are the 0 and the 4. So we can ignore the 1, 4, 6, 9 and the 2 and 8. Okay, so now here's a table that will help us visualize things. So I purposely did not put anything after 6 here or after 5 because the factorials all going to have a factor of 10, so they're going to end up with a 0. And these, after 6 here, the 6 times n factorial plus 3 is going to end with the 8. Okay. So what I did was I compared these now. So I'm comparing these two columns. So we have 24 is the first number here, and I don't see it in my list. 30, I see it here. 54, I see it here. Now 162, I purposely went up to 13, n equals 13, to see if 162 was on my list. I know that 738 is not going to be on my list because 8 was not the last digit from this. So if we recall, p squared plus 5 did not have an 8 as a last digit. So I purposely went up to 162 because, well, technically I guess 2 is also not a part of the list for p squared plus 5. So technically I guess I didn't have to go that far. But it's at least good to see why going to n equals 13 is maybe a safer option. So from that, we clearly see that 30 and 54 are going to be the answers. So, well, when are they equal to 30 and 54? Well, n has to be 2, p has to be 5. Okay, so n equals 2, p equals 5. And then when it is equal to 54, n equals 3, and p equals 7. And those are our only answers.